Hi everyone. We're going to do basic simple recursive sequences and write out the first 5 terms. The first thing you probably already know that ace of 1 is the first term. Ace of n means the nth term. And when you read ace of n, I call this minus little 1. Remember, this is not ace of n minus big 1. Be careful with your handwriting. This just means the previous term. And if you can think of it that way, it makes it easier. Previous term. And I think I have 7 problems here to do. So we'll go a little slow the first time. A recursive formula gives you the first term and then gives you the nth term. And you use the previous term. Sometimes it gives you 2 terms. Like the Fibonacci sequence, you need the first 2 terms. These are all just basic introductory recursive sequences that you just need the first term. So basically, we already have the first term. So we need the second term. We need the third term, the fourth term, and the fifth term. All right? So I'm going to use this formula here. The second term is negative 2. Now, if you want to look at this, just look at this for a minute. If you put 2, because our n is 2, so ace of 2 minus 1 is ace of 1. So basically what we're saying, it's just the previous term. Our previous term, ace of 1, is negative 2. So ace of 2 equals 4. All right? Ace of 3 is, copy down the negative 2, times, and just read this as the previous term. The previous term was 4. So that gives you negative 8. Ace of 4 is negative 2. Just, what's the previous term? Previous term was negative 8. That gives you 16. And after a while, you can probably see, without even doing this, you don't have to write the formula out. You can just see the pattern. We can just see by the pattern that this is going to be negative 32. Anyway, I'll go ahead and write it. This is times 16 equals negative 32. So these are just basic recursive formulas. And if you read this as the previous term, like I said before, it makes it a lot easier. All right, next one. They're giving you the first term and they give you the nth term. So basically, we want ace of 2, ace of 3, ace of 4, and ace of 5. So ace of 2 equals, my n here is 2. So if you do your n equals 1 here, equals 2, 3, 4, and 5. So ace of 2 is just 2 minus your this means your previous term. Your previous term is 3. So this equals negative 1. Okay, your third term, you write your n. Your n is 3 minus your previous term. Our previous term is negative 1. So it's minus 1. That equals 4. Okay, ace of 4 equals, I'm just writing 4 minus my previous term, which is 0. And here, ace of 5 is you write 5 minus your previous term, which is 5. Okay? Next one. I need my 5 terms. All right, and my n, if I look at my n's here are 1, 2, 3, 4, 5. These are my index numbers. All right. So ace of 2, my n is 2, equals 2 plus your previous term. And that equals 0. All right, ace of 3 equals, right, 3 plus what's your previous term? It is 0. So 3 plus 0 is 3. ace of 4 equals 4. These numbers are matching here because that's your ends, plus your previous term. So that equals 7. And the last one, ace of 5, equals 5 plus your previous term, which is 7, and that equals 12. Okay. Next one. Ace of n is negative 1. So, this is ace of 1, sorry. Ace of 1. So now we need ace of 2, ace of 3, ace of 4, and ace of 5. So ace of 2 equals 4 minus your previous term. My previous term is negative 1, so that equals 5. Ace of 3 equals 4 minus your previous term. I can just look there. My previous term is 5. That equals negative 1. Ace of 4 equals 4 minus your previous term, which is negative 1. That equals 5. And ace of 5 is your previous, or it's 4 minus your previous term, which is negative 1. In this case, what we have is this oscillating effect. It's oscillating back from negative 1 to 5, negative 1 to 5, negative 1 to 5. So, okay. The rest are very similar. Maybe I should just let you do these. I'm just going to go really fast. All right, so ace of 2 equals 3 minus my previous term, which is 1. Ace of 3 equals 3 minus my previous term, which is 1, equals 2. Ace of 4 equals 3 minus my previous term, which is 2. That equals 1. Looks like we have another oscillating type thing. 3 minus my previous term, which is 1, equals 2. So again, we have this oscillating effect here. 2, 1, 2, 1, 2. All right, 2 more. I think this is going to be oscillating as well. So let's see. Ace of 2, ace of 3, ace of 4, and ace of 5. Let's see. Ace of 2 equals 4 minus 3. Ace of 3 equals 4 minus 1. Do you see the pattern? Ace of 4, this is 3, equals 4 minus 3, which is 1. So you get the same oscillating type pattern. And now we have one that's a little different. We need ace of 2, ace of 3, ace of 4, and ace of 5. Our first term is 1. So my second term is, my n here is 2. So 2 plus 3 times my previous term. So this is going to be 8. All right. Ace of 3 equals 3. These numbers match. Plus 3 times my previous term, which is 8. Uh-oh. I didn't bring a calculator. This is 27. Oh, Lord. All right. Ace of 4 is 4 plus 3 times 27. So that's going to be, oh boy. Okay, it's going to be 3 times 27, which is 81, plus 4 is 85. And then we have ace of 5 is 5 plus 3 times 85. 3 times 85 is 255, plus 5 is 260. Okay. And that's all. These are the basic, simple recursive formulas. Thanks and have a nice day. Bye-bye.